Hello, I'm Rachel Shipsey and I work as an operational researcher in the Data Linkage methodology team at the Office for National Statistics in England. The next census in the UK is in 2021, and today I'm going to talk to you about the improvements that we have made to our linkage algorithms, which hopefully means that we'll be able to produce census outputs within 1 year. Our task is to match both people and household from the census to the Census Coverage Survey. The Census Coverage Survey, or CCS, is a 1% sample of postcodes, and this sample survey is carried out just after the census. The matching is used to determine the undercount, that is, people who've been missed from the census, and the overcount, people who've been counted more than once, and it feeds into the estimation process. Now, the estimation process doesn't deal very well with errors in matching. In effect, every false negative or missed match adds 100 extra people to the census count. And similarly, every false positive or incorrect match causes the census count to go down by 100. So our accuracy targets have to be extremely high. Unlike other countries, in the UK we output estimates rather than counts. So this means that our estimates have to get out in a timely manner. So we have to do the matching really fast, but still be really accurate. We have 8 weeks from the time we have all of the census and CCS data to complete the matching. So that is pretty short, but we do also have a tuning period beforehand where we'll have some of the data, and we'll be able to use that time to fine tune our algorithms. Here's a whistle-stop tour of our methods. First of all, we're going to use deterministic matching to make the easy matches. We've developed a series of match keys that allow for different kinds of errors in the data. These include fuzzy matching, using both Soundex and Jarrow-Winkler string comparators to help us catch scanning and phonetic errors, but also alpha name, which is all the letters in the name put into alphabetical order. This helps with typing errors where letters might be accidentally transposed. For our deterministic household matching, we have replaced the head of household variable from 2011 with sets of names, dates of birth, etc. And we use these to match across households, along with household characteristics such as type of property. We look for a forename match, a surname match, and a date of birth match across a household, rather than insisting that these all come from the same person. And this is good because the person chosen to be the head of household on the census form might not even be present on the CCS form. The match keys are based on 2011 data because that is the best training data that we've got. However, we know that the 2021 data will be different because 2021 is an online first census and people's attitude to government and data collection has changed. So the data might be better, or it might be worse, or it might just be different. To account for this, we're not relying solely on the match keys, but we're also implementing a Felighi-Sunter probabilistic method because it's not reliant on test data. In 2011, there was lots of blocking passes used to bring together possible candidates for the Felighi-Sunter algorithm. But in 2021, we don't need to do that because our distributed computer platform allows us to quickly generate billions of candidates pairs just by blocking on postcode. This means that our pairs completeness is very high because nearly all matches will agree on postcode, and we're not excluding any possible matches by having to insist on other variables matching at this stage. The few matches where postcode doesn't match would have to be clerically reviewed in any case and will be picked up at a later stage. We're going to use active machine learning to optimise the algorithm parameters as we make matches. And the algorithm basically splits candidate pairs into two groups, matches and non-matches. Because of the high accuracy requirement for our matching, we have a third group in the middle that are maybe matches, and these are sent to clerical review. The pairs with the highest probabilistic scores should mirror the deterministic pairs, and if there are significant differences, we will have a warning that something's gone wrong with the match keys and be able to tune them. We're also going to make use of associative matching, that is using matches that we've already made to help us make some more matches. So for the unmatched people in matched households, we use a probabilistic algorithm to give them a score. If they score above a threshold, which can be a little bit lower than for the original people matching, then we'll accept them automatically. All other unmatched people in matched households are sent to clerical review. In this first example here, the household and the adults have been matched automatically, but the child looks a little bit different, so is sent to clerical review, along with the dog who has erroneously been included on the census form. The clerical matcher should be able to match the child and mark the dog as out of scope. In the second example, the person has been matched automatically, but the household does look a bit different. So the clerical review will have to decide if this is the same address or not. Improvements to our algorithm since 2011 mean that we expect to automatically match up to 91% of people compared with 70% in 2011 and up to 95% of households compared with 60% in 2011. But there is still the need for some clerical work, and we've also made massive improvements to our clerical matching system so that both accuracy and speed should be improved since 2011. For example, we present people in their household so that matchers can make use of family associations and make several person matches on the same screen. We found that this is much more efficient than presenting all possible pairs separately. So the improvements that we've made to our automatic matching and clerical matching mean that by this point we've hopefully found around 99% of the matches, but there's still that really difficult 1% to match, and the problem is that remaining 1% of records that do have a match are hidden within the thousands of records that genuinely don't have a match. So what we're left with now is a problem of declaring the status for a record. Is there a match for it or not? It's not just about finding matches at this point. In 2011, this stage was carried out using clerical search, i.e. here's a target CCS record, see if you can find a match for it in the census dataset. This is very slow, and particularly for records that don't have a match, because how do you know when to stop searching? In 2021, we'll instead be using a pre-search algorithm, which presents the clerical matches with a list of the best possible candidates. And if there are no matches in this list, then we declare the record as unmatchable. This would be much quicker than clerical search. So with the improvements that we've made to automatic matching algorithms and the clerical matching system, we should be able to match the census and the CCS to the required accuracy in a given time. But that comes with a caveat, because did any country ever have a census where nothing unexpected happened? And we are living in a very uncertain world at the moment, so I'm not actually going to make any promises. Thank you for listening.